Okay, this is our class on land navigation, and we have our 5 major terrain features, which you can remember with hidden, valley, range, salad dressing. So hill, valley, ridge, saddle, depression, and you could also remember that by looking at your fist. So your knuckles would be the hills, the valley would be your cupped hand, and you could also use that for depression. And for ridge, that's a series of hilltops, so that's your knuckles, and then saddle would be 2 isolated knuckles. And so here we have a hill, and that's concentric circles that get progressively smaller. And the difference between the lines is called the contour interval, and that's usually denoted on the map, which would be something like 10 meters or 15 meters. So like this would start at 0, 15, 30, 45. And over here we have a valley, and that's contour lines that come together, and they start farther apart, and they come towards closer to each other. And in the middle there'd be nothing, and usually there's going to be water flowing through that, which is how you notice it in the map, which would make it stand out. So here we have a ridge, and a ridge is a series of hilltops, like I said earlier. So same thing with the contour intervals, you'd be able to find like the height of it. And here's how a saddle would look on a map. And here we have a depression, which is noted by tick marks going inwards. And so we'll orient you over to
Okay, these are the minor terrain features on a map, which are spur, draw, and cliff. On a spur, it's when using your fist. It's the knuckle and the fingers. When and a draw is more like in between the knuckle and the fingers. And sometimes there's a water source flowing down there. And a cliff is when the contour intervals come together, and there are tick marks facing out. And you can denote this by the side of your hand.
I'm going to be discussing the colors on the map. The first color is red. It represents cultural features, populated areas, and roads. And it's also not red light readable. The second color is green, which represents vegetation such as forests and fields. The third color is black, which represent man-made structures like buildings. The fourth color is blue, which represents any water source like lakes and streams. The fifth color is red-brown, which just represents the contour lines on the map. And the last color is brown, which is basically like red, but it's red light readable.
Hi everyone, this is a military plotting class, and for plotting you need a protractor, a map, a 6-digit or any digit coordinate, and a utensil to write with, a pen, pencil, or for this case, a chalk. So the first 2 numbers correspond with the numbers up there, and the 5th and 6th numbers correspond with the numbers on the side, and that'll give you a box to work with. And Caulfield's going to talk about the accuracy of all the grid coordinates.
Alright, so when given a set of grid coordinates, the amount of digits given corresponds with the accuracy of the map. So if you're given four digits, you're going to have 1,000 meter accuracy. With 6 digits, you have 100 meters, 8 digits, you have 10 meters, and 10 digits, you have 1 meter. So here we're given 8 digits, so that's 10 meter accuracy. The easiest thing to do when plotting is to take your digits and divide them in half, because this is going to be your horizontal, and this side's going to be your vertical. So in this case, we're given 43 as our first number. So we're going to go to our horizontal and go over to 43. Right here, this line right here. The second set is going to be our 86. So we're going to go to our horizontal, or excuse me, our vertical, no, our horizontal. So we're going to go 86, and we're going to go to the point where these two intersect, and we're going to go to the left side of them. When looking at your protractor, you want to make sure that the scale that you're using matches the scale of the map. In most cases, the scale of the map is going to be 1 over 50,000 meters, and but the easiest way to check is just to see if your scale matches up with the boxes on the map. Now that you have your intersection of the box that you're going to use this box right here. You're going to take your protractor and you're going to look at your second set of digits. So you have 40 on this side, so you're going to take your protractor, match it up with that corner, slide it over to where 40 meters on the scale matches up with the corner of the map, and then you're going to take your second set of digits, which is 80, and just move up to 80 on your scale, and you're going to find where that point is on your map. And that's how you plot a point.
This is our second part of our plotting course, and here on the map we already plotted 2 points, so we're going to show you how to find the distance and direction. So using the protractor, like we said earlier, you find the right triangle, and the triangles are broken up into the x and y axis you can think of. So each one is comprised of 1,000 meters. So you put the protractor up here and you start at one point, which you put in the corner, and then you go 1,000 meters, and then you mark it, and then from this 1,000 you do it again, and then you get the complete distance. So here is about 1,500 meters. So we would write that, you could write that down, and from that you find the direction. So you find the direction by putting one point in the center of that circle and then using a flat object to find the azimuth. So here, this correlates to 43 degrees. So after you have your distance and direction, you have to take into account the GM angle, which is your grid to magnetic, which is how you convert your grid north to your magnetic north. So our GM angle is plus 13. So like I said earlier, we had 43 degrees. So we'd add 13 degrees to 43 to get 56 degrees, and that would be the azimuth you'd go on with your compass. So like we said earlier, you orient yourself to your compass, you find 56 degrees, and you head in that direction. And to use the distance in the compass, you have something called a pace count. So you do pace verification, so you'd walk 100 meters, and say every time your left foot hit, you count that. So you walk 100 meters, and your left foot hits 60 times. So that's how you find the distance. So you're walking 1,500 meters, and every 100 meters, it's 60 steps.
I will be talking about the actual map itself, not just plotting. Here you have your, your x-axis, and your y-axis. That's what Proj talked about, but I'll be talking about what's on the bottom and what actually gives you the guidelines to follow through while you're plotting your map and going through your land navigation. On your left corner, on your left bottom corner, is the legend. It's what Justin talked about. It's your terrain features and the colors of the terrain features. And the scale is what the map will actually go by. So if it was going by 50,000, 1 over 50,000, 1 over 25,000, that's how it's going to be. And on the right bottom corner, it's actually pretty important. There's a lot of stuff, but I'm going to be going over the basic stuff. And on the bottom right hand side, you could actually find a GM angle. That's very important. And it's actually going to go over the contour lines, which also goes over the elevation. You guys how to use a compass with an azimuth and a distance. Alright, first I'm going to talk to you about the actual compass. This is how a compass looks like. My drawing of a compass and the actual of a compass. I drew it because you would not be able to understand what I'm talking about. First, on a compass there's a west and east, and it's with north and south, presumably. And the inside, there's two types of tick marks. There's a red tick marks, which go by the 20s. And you can, at least, I'll talk about that later, and then the outside tick marks actually go by intervals of 1. So if you were given an azimuth of 180, you would actually go to the red tick marks, which are the inside tick marks, and find 180, and then you would actually go, if it was 186 degrees, you would actually go to 180, which is in the inside tick marks, and then if you want to find it to the one-digit numbers, you would go to the black tick marks, the outside tick marks, to find the exact 186 degrees, and which you can, and you have a distance of 380 meters. So that you set your azimuth, that's what it's called. Set your azimuth to 180 degrees, and then this is how you actually move through the woods or wherever you're going. There's two different ways. You can dead reckon, which is where you pick a certain object or certain feature that you want to pick. You want to pick out a feature, and then you want to pick that feature, and then you want to start walking through it. So what I'm going to do is I'm going to pick that projector. You can actually show them the projector. I'm going to set it to, I already have set it to 180, and what my azimuth points to is that projector. So what I'm going to do, I'm going to walk to it. I'm going to walk, and then I'm going to stop. I'm going to stop, and then I'm going to set my azimuth again to 180, and then I'm going to pick another thing. It could be this chalkboard. I'm going to walk to the chalkboard, okay? Then I'm done. So if you keep doing that until 380 meters.
This is the physical fitness portion of our presentation, and here we have high-speed cadet private Proj Sahu, and he's going to demonstrate the push-up, which is one of the events on the physical fitness test. And the push-up is test your chest, triceps, and shoulders, and your muscular endurance. So Proj, it would start with get ready. And in the get ready part, you can have your knees on the floor. And then the grader will say get set. And here's when you get into the actual push-up position, back flat, knees not touching the ground. And you say go, and start push-ups for 2 minutes. And if you notice, he goes down till he breaks the plane of his elbows, and then he comes back up and he locks his arm. And the whole time his body moves as one single unit. So he's not humping the ground, and yeah, that's not a push-up. And so if he were to do that or put his knee to the ground, if you put your knee to the ground, you're terminated. If you lift your hand, you're terminated. So the proper way to move your hands is kind of inch them out, keep them on the ground. Yeah, so you can move your hands in and out once you hit muscle failure, and that'll help you get some more reps.
Here we have our second portion of the PT test. It's actually, the exercise is the sit-up. In this exercise, you actually need two people. We need a spotter, which is Cadet Sahu, and the person that actually conducts the exercise, high speed, Greenmeyer, aka sexy, good looking, as you can see. There's actually key guidelines you could follow to perfect the sit-up, which Greenmeyer will show you. Can you do a sit-up for us, please? All right, stand still. You must interlock your fingers behind your head to be completed as a rep, and the rep is not completed until the cadet actually goes all the way down and hits the ground to his back. That is one. That counts as one. Can you do one more? Two. It does not count as a rep until you touch the ground with your back.
All right, the third and final part of the PT test is the 2-mile run, demonstrated here by high-speed cadet Justin Kim. All right, during the run, it's important to maintain good posture, because good posture is key to success in your run. It's important to keep your body aligned, your core tight, and during the run, you want to bring your knees up and not have them go too far in front of your body. When this happens, you're actually exerting a force back at yourself, slowing down your time. So what you want to do is bring your knees up and kind of have your body leaning forward. That way you're letting gravity take you, and you're just springing off. During the run, it's important to breathe in through your nose and out through your mouth. And also to keep in mind that the minimum time to pass the 2-mile run is a 15:50.
6.